In this video, we're going to be talking about quadratic functions and data. So, when given data that follows a parabolic trend, we use technology to write quadratic functions that best fit the data. Now, got this phrase parabolic trend. Well, we know that the word parabola is used to represent the shape of a quadratic, and that is just a U-shaped graph. So here, remember, our quadratic functions can either open up or down, so you can expect to see that. Now, when we are finding our quadratic trend lines on the Inspire, that's what we're using today when we reference the word technology. Our steps are going to be to type in the X and Y values into list and spreadsheets, but we are actually never going to leave list and spreadsheets. So these steps are going to be a bit different from steps 2 and 3. We will then stay in list and spreadsheets, and then to find the equation of our quadratic, we are going to press menu 416. Now, pressing menu 416, guys, this is going to actually go ahead and give you the values of A, B, and C of your quadratic function. So let's go and take a look at number 1. Number 1 said Taylor attended a concert with her friends. During the concert, the singer threw a t-shirt h of x at different horizontal distances from the stage. Using technology, input the table of values and complete the missing information. So remember, left column are your x's, or the right column are your y's. So we're going to go ahead and start off by coming over to our calculator, and I am going to open up a list and spreadsheets window. Anytime you are given a table of values and you're trying to find the equation of that table, go ahead and put it into list and spreadsheets. So I'm going to go up to cell A, and I'm going to type in X, and I'm going to go over to B, type in Y, and then from here we are entering in our data. So you should have a total of 5 points. So once you have your table of values, again, you should have 5 points here. Guys, when you are looking at these problems, you need to be extra careful that you are checking to see if your function is a linear function or a quadratic function. And this problem specifically doesn't tell you that it is linear or quadratic, but for the purposes of our notes in this unit, we know that it is quadratic. When you do look at problems on specifically like the STAR test, it will specifically tell you if it is a linear function or a quadratic function. So you always want to check out for that. So to find the equation of our function, we are now going to go ahead and press menu, 4 for statistics, 1 for stat calculations, and we are going to come down to quadratic regression. So again, that is menu 416. Please do not get this confused with number 8, which is a quartic regression. We want a quadratic regression. So again, menu 416. X goes in my X list, Y goes in my Y list, and then we press the enter button twice. Now here, this is going to give me the values of A, B, and C. So the value of A is negative 0.08, B is 1, and C is 3. So from here, again, I'm putting this into the form of ax squared plus bx plus c, because again, this is a quadratic. And my function is negative 0.08x squared plus 1x is just x. And then the value of c is 3, so plus 3. So before we go ahead and identify the key features of this function, we want to go ahead and graph this. So my first point is at 1 and 3.92. So here's 1, and then 3.92 is going to be slightly below 4. Then I have 3 and 5.28, so 3, and then 5.28 should be slightly above 5. 5, 6, so here's 5, and then 6 will be right here. Then we have 7 and 6.8, so it should be slightly above 6. And then 9 is at 5.52, so about 5.5. So it should look something like that. So now from here, I want to go ahead and identify the x-intercepts, the vertex, the y-intercept, and the axis of symmetry. So what I'm actually going to go ahead and do is I'm going to go ahead and connect my dots. Now, this isn't specifically going to actually tell us when, or this is not going to identify these specific functions. But from here, guys, to identify these functions, what we're going to go ahead and do is we're going to open up a graphing window. And we are going to type in the function. So negative 0.08x squared plus x plus 3. When I press enter, this is what my graph looks like. Now, I cannot see the full shape of my graph, so I'm going to go ahead and zoom out by pressing menu 4. So here, I'm just going to go ahead and press the enter button one time, and we can now see that my graph has zoomed out, and I can see all the different parts of my function. I can see my x-intercepts, I can see my vertex, and I can see my y-intercepts. So from here, we're going to press escape. Now, the first thing this graph is asking us for are the x-intercepts. So we're going to go ahead and press menu, 6 to analyze graph, and remember our x-intercepts, again, are menu, 6, 1. So I'm going to go ahead and press 1 for 0. I'm going to look at my first x-intercept. I'm going to place that dashed line on the left side of my x-intercept. I'm going to press enter and then scroll over. So here my first x-intercept is at negative 2.5. Slash, now I have a second x-intercept. So menu 6, 1 again. I'm going to place my dashed line on the left side of that x-intercept. I'm going to press the enter button and then I'm going to scroll over. Here I see that my second x-intercept is at 15. Now guys, when it comes to a real world situation, I want you to really think about what really should represent my x-intercept. Remember, we're talking about distance in meters. Does it make sense for me to have negative 2.5 meters or 15 meters when I'm talking about this real world situation? No, it makes sense for this to be at 15. So the graph that we drew here doesn't accurately project the x-intercept because our x-intercept on this function should actually be here at 15. So I'm going to go ahead and erase this, and I'm going to go ahead and try and have my graph go through my x-axis. So it should look something like this, or my x-intercept. Okay, next up, I want to identify the vertex. So to identify the vertex, remember, you have to start off by checking to see if our graph, if this is the lowest or highest point on your graph. Well, this is the highest point. So because this is the highest point, this is our maximum value. And so because it's my maximum value, I can press menu, 6 to analyze graph, and 3 for maximum. So here I have this dashed line. I'm going to place this dashed line on the left side of my vertex. I will press enter and then scroll over. So here I see that my vertex is at 6.25, comma 6.13. Now guys, what does our vertex represent here? Well, this represents that, again, my x value is meters. So after traveling 6.25 meters, the t-shirt will be at a height of 6.13 meters. That is what this point, our vertex, represents. Okay, next up, we want to identify our y-intercept. So remember, when we are identifying our y-intercept in our calculators, we are finding that by pressing menu, 5 for trace, and then we are pressing 1 to graph trace. What your calculator is going to do is it's going to give you a bullseye. We want to make sure that that bullseye is at where x is equal to 0. So if you notice when I pressed it, I had 0.9 and 3.84. I'm going to press the left button until I see that my x value is at 0. And here, my x value, my y-intercept, whenever x is 0, is 3. So here, my y-intercept is 0, 3. Now, typically, guys, when you do press menu 5-1, it typically does give you the y-intercept right away. But I think because there are so many points that are already on this graph, it kind of needed a little bit more help to get to the y-intercept. Okay, next up is your axis of symmetry. So remember, your axis of symmetry is the x value of your vertex. So here, the x value of our vertex is at 6.25. So here, my axis of symmetry is going to be x equals 6.25. Now, when it comes to identifying your maximum and minimum, remember that is the y value of your vertex. So we already determined that this was a maximum because it was the highest height, but we're going to say it's a max at 6.13. Again, your minimum or maximum value is the y value of your vertex, and your axis of symmetry is the x value of your vertex. Okay, next up, we want to determine the domain and range. So remember, the domain are your x values. Here we go from left to right. So if I go as far left as possible on my graph, I see here that I am setting up a boundary at 0. Then I go as far right as possible. We know that my boundary was drawn at 15 because that is where my second x-intercept is. That is where that t-shirt hit the ground. So remember, two boundaries means I should have two numbers when it comes to setting up my domain. So I'm going to go ahead and put my variable first in the middle. And then I'm going to draw my boundaries from least to greatest, or list my boundaries from least to greatest. Now remember, when we have two boundaries, our inequalities are always going to face in the same direction, because this tells us that our x values are in between 0 and 15. And then again, remember, in a real world situation, we always have lines underneath our inequalities. Next up, let's talk about our range. These are the y values. We are going from the bottom to the top. So here at the very bottom, I'm setting up my boundary where that t-shirt hits the floor, hits the ground. It is at 0. Then I'm going all the way to the top to my vertex. So remember, our vertex was at 6.25, comma 6.13. Guys, remember that your range is always set up at the vertex, and our y value on our vertex was 6.13. So 6.13, this is where my boundary line is being set up. So guys, here I have two boundaries. Two boundaries means I should have two numbers when it comes to setting up your range. So again, I'm going to start off by placing y in the middle, and then I'm going to list my boundaries from least to greatest. From here, I'm going to go ahead and throw in both of my inequalities. Again, these will always be less than when we have two boundaries. And then I'm going to add lines underneath my inequalities. So that's domain and range. Okay, next, predict the height of the t-shirt when its horizontal distance from the stage is 10 meters. Okay, horizontal distance from the stage. First, I need to determine what piece of information is that, x or y. Well, distance from the stage is my x value. It tells us so on the graph. Distance is my x value. So here they gave me the variable x. So from here, guys, what I'm going to go ahead and do is I'm going to go ahead and press Control T. And I'm going to go to where x is equal to 10. And I see here that the height is 5. So I'm going to go ahead and say 5 meters. Okay, next up, the last question says, describe the meaning of the vertex in the context of the situation. So we kind of already touched on it a little. I kind of explained it earlier. My vertex is 6.25 and 6.13. Well, what that means is that at a horizontal distance of 6.25 meters, the shirt will reach its max height of 6.13 meters. So guys, anytime you are being asked to reference to your vertex, always reference back and look at what the variables of your x and y value represent there. Okay, next up, let's take a look at number 2. Number 2 says, Gino used a water balloon launcher to launch a balloon at his brother. The table shows the height of the balloon, f of x, at different times. So here, guys, we're going to start off by clearing out our calculator by pressing Control W. No, you do not want to save anything. You have to clear out your table every single time. So we want to use technology to find the values of a, b, and c, and then we will rewrite the function in standard form to represent the data. So we are going to open up a list in spreadsheets window. Now guys, on a horizontal table, top row are your x's, bottom row are your y's. So I'm going to go up to A, type in x, and then I'm going to go over to B, type in y. And then I'm going to enter in my data. So we're going to start off by entering in all of our x values. And then we're going to go over and we're going to type in our y values. So now that we have our data inputted, we want to make sure we are in an empty cell. Again, to find the values of A, B, and C, we are pressing menu 4, 1, 6 for quadratic. Here, I'm going to type A in our A list, X in our X list, Y in our Y list. Then we will go ahead and press enter twice. So here the value of A is negative 16, the value of B is 40, and the value of C is 2. So here my function is f of x equals negative 16x squared plus 40x plus 2. So we now want to use our function to predict the height of the balloon after 0.75 seconds. So 0.75 seconds, this is my x value. Now, typically, guys, here I would suggest that you go ahead and find your table of values or find that value in your table of values. However, when this is a decimal, you cannot do that. So what we're going to have to do is we're going to have to plug 0.75 in for x. So this is going to be negative 16 times 0.75 squared plus 40 times 0.75 plus 2. So here, let's go ahead and open up a calculator window, and we are typing in negative 16 parentheses 0.75 squared plus 40 times 0.75 close parentheses plus 2. Now, when I press enter, I end up getting 23. So here, this equals 23 feet. Guys, you're going to go ahead and scratch out these next two problems. We're not going to go ahead and do them. So scratch them both out. And we're going to move on to number 3. Number 3, the path of a ball that is kicked upwards can be described by the equation f of x equals 35x minus, this should be 5x squared, where y is the height of the ball in meters and x is the time in seconds. How high is the ball after 3 seconds? Okay, guys, so they have already given me the equation, and I am trying to find how high the ball will be after 3 seconds. Well, seconds is my x value. So here, guys, what I'm going to go ahead and do is I'm going to go ahead and start off by typing in my function into graphs. So 35x minus 5x squared. Now, I'm going to go ahead and press enter. This is what my graph looks like. I cannot see the full shape of my graph. So I'm going to go ahead and zoom out by pressing menu 4. And I'm going to press the enter button until I can see where my vertex is located. Now that I can see my vertex, I'm going to go ahead and press escape. Now, again, the question wants to know how high is the ball after 3 seconds. So you have two different options. One, because I know that 3 is my x value, I can say 35 times 3 minus 5 times 3 squared. All I'm doing is plugging in 3 for x. Or I can press Control T and I can go to where x is 3 and I see that I should have the height of the ball should be at 60 meters after 3 seconds. Next, the question says, what is the highest point the ball will reach? What time is it? So guys, if I'm asking you to find the highest point, that means I am asking you to find your vertex. So we're going to go ahead and press Control T now. This is going to close our table, and we just have our graph again. So when I look at my point, again, I notice it is the highest point. And so that is called my maximum value. So to find my maximum value, I'm going to go ahead and press Menu, 6 to analyze graph, and 3 for maximum. So here I have this dashed line. I'm going to place that dashed line on the left side of my vertex. I'm going to press enter and then scroll over. Here I see that my vertex is at 3.5 and 61.3. So what that means is that after 3.5 seconds, the ball will reach the max height of 61.3 meters. Okay, let's look at the last problem, number 4. Amy has 40 feet of fencing to create an enclosed rectangular area for the new chicks she purchased. The table shows some of the possible lengths she could choose and the resulting area it would create. Use technology to write a function in standard form to represent the data. So, start off by clearing out your calculator, Control W. No, you do not want to save anything. I am opening up a list in spreadsheets window. Now, remember, top row are your X's, bottom row are your Y's. So, we are going to go into list in spreadsheets, and we are going up to cell A, and we are going to type in X. Then we are going over to B, and we are going to type in Y. From here, we are entering in our data. Now, remember, when you are in list in spreadsheets and you are trying to find the equation of a quadratic function, the command is menu 416. X goes in your X list, Y goes in your Y list. Press the enter button 2 times. Here I have an A value of -1, a B value of 20, and a C value of 0. So here this would be f of x equals -x squared plus 20x. Next, the next question wants us to determine the rectangular area if Amy chooses a length of 9 feet. So having a length of 9 feet, this is my x value. So again, there are 2 options I can take. I can plug 9 in for x. Because this is a whole number, I can also go ahead and open up a graphing window, and I can type in -x squared plus 20x. Then I can press enter, and I can press Control T, and I can go to where x is equal to 9. And I will see that when I have a length of 9 feet, I can expect to have an area of 99 feet squared. We're going to go ahead and cross out the last questions. We're not going to go ahead and do those. And that is going to go ahead and complete your notes. So now when it comes to your assignment, I am only going to assign a few problems to you. So I want you to circle number 1, number 2, moving on to the back page, number 11, number 12, and number 13. Those are the only problems you have to complete on this assignment.